5 a.m. Pacific Standard Time. Beautiful Palo Alto, California. Thank you for joining our office hours. We'll be kicking this off in about 5 minutes, top of the hour. Until then, it'll be mute. Good morning, good afternoon, And good evening to our global community vision community. Excited to have you at our office hours today. Just a few housekeeping. This is a recorded session. It's also a live session, which we're very excited to present. For any questions that you have, please access our live event page and post your questions there. And then we will answer the questions during our live Q&A with Erica. We'll send a follow-up email tomorrow with the recording and any questions that didn't get answered. We appreciate your time today. And with that, take it away, Erica.
Awesome. Thank you, Adrian. We're so grateful to be here today and just chat with you all about your computer vision questions. We did get a few in advance of the session, so that's always great to see. Our agenda will be pretty straightforward today based on that sort of concept of office hours, but we will also walk through a few example use cases. And the goal from that perspective really is to look across different industries and see where computer applications are adding value and see that it's not just one type of solution where computer vision applies. It's everywhere, and we all know that because we have cameras that we use all day every day. And in addition, I'll also showcase new feature capabilities that are part of our regular release cadence, which is quite impressive. And I'll point you to documentation around those capabilities and those release notes, and of course the Q&A. And of course, I'm Erica Gilbert. I have been working in the deep learning space for over 5 years, so I've seen a lot of different types of problems that deep learning helps solve, and hopefully can help address and answer any questions today. But as we go through the presentation, I'm going to go ahead and turn off my camera just so we can all focus on the content here. So, of course, very common in the vision space is looking at manufacturing. We know manufacturing is one of the fastest and earliest to adopt AI solutions. And that's because in those manufacturing plants, there's a lot of vision systems already in place. Many of those systems are using traditional computer vision methods to do measurement and review of data that's very straightforward. But the benefit of AI obviously comes in to allow for human subject matter understanding to be an assist or help fully automate those processes for inspection. And of course, that provides a lot of value around increasing the inspection time. So making the operators who are working in this case with an X-ray door inspection lives much faster with a pretty onerous inspection process where they have to look at sort of 3 different points of inspection, and applying an AI system that is able to automate that process. So taking the manual inspection process, which has sort of different levels of accuracy depending on the type of inspection and the humans working on the line. In this case, the example here is 50 to 60%. And going all the way up to 99.7%. So really tremendous increase in accuracy, and helping make those operators more comfortable in the role, reducing turnover. So a lot of soft ROI benefits coming with that type of system. And it integrates directly into the systems the operators are already working with. So they're able to look at a monitor that they've been working within day in, day out. And they can also focus their inspection talents in other areas as well. So it allows them to layer in other complexity and use that time, going from 1 to 3 minutes. So the 2 to 3 seconds where AI can then analyze that X-ray door for the screws to see, the count position and just really verify that it's actually good. This then has big impact at the end of the day when you think of the actual product that comes out, because there are way less issues with returns and then therefore warranty claims. So big ROI and big process change, but a little bit in addition to the why, like why actually pursue this with AI, but also looking at the how. So in this case, um, the the customer is actually leveraging Landing AI in a very straightforward way. So one of the most straightforward models to develop in the platform is a classification model. So whole scene image analysis to understand what looks good and what is not good for very complex image sets. So being able to take those high resolution uh, images from an X-ray machine that ultimately was very cost intensive to set up that image acquisition system and leverage that in the LandingAI LandingLens to build a model and then deploy it ultimately through our inspection interface with Landing Edge or inspection point. Those results are then parsed into software uh, directly in the operator's field of view to see okay or not okay. So it's seamless from the perspective of the day-to-day, and with some simple programmatic software development, very straightforward to create with LandingLens. And of course, no data scientist actually is required. So it's important to always think back. A lot of times when we're looking at vision applications, LandingAI and LandingLens and Landing Edge are pieces of an overall solution for customers. And we spend all day, every day, assisting our enterprise customers with plugging in all of the pieces of what that actually is. So what does the data look like? What is the modeling? Do we need more than one model to solve for your specific process? And where ultimately is this going to live, and how are you going to parse those results? So this is a great example of tremendous value in the manufacturing space. But as I mentioned, it comes across all industries. So here with our partner Marvic, who is a ML solution provider, we were able to showcase the ability to calculate brand shelf share. So if you think about going into a grocery store and the immense number of products and the amount of brands that exist on those shelves, it's pretty challenging for you as a uh, owner in the store to be able to task either your team or yourself to go through and manually review and calculate that brand percentage, especially as you bring on new products and it evolves over time. And as humans, we're probably not as reliable as a machine system in sort of that counting. I'm just imagining how overwhelmed I get when I walk into a grocery store aisle. So there's a lot of times this process can just be completely ignored for other, you think about what is an impactful task and what is an important. And sometimes we sacrifice the impactful for the day-to-day important. And that's the case here. Using AI, you can do that calculation and not have to input all of that data on the spreadsheet yourself and really save that time, but also that margin of error. And with Landing AI, that's pretty seamless pipeline that Marvic was able to leverage to be able to provide a solution like this, which, again, as I mentioned, reduces that inspection time, but also provides ability to be maybe potentially more strategic with the store layout and planning as you think about what brands are presented and which ones are perhaps outperforming others. So a lot of consideration and ability to do more with ultimately less time. So that's the value there for a particular retail use case. But when we think about what the components are from a LandingAI perspective, it's really looking at imagery. So if you think about aisles in stores, they are quite long. So as you take that sort of field of view, you have to bring those components together so that the model can accurately count for that aisle the number of products. And then, of course, it's looking at object detection model. So it's one of the most common questions we get for customers coming into the platform is what project should I build? Should it be object detection? Should it be classification? And if ultimately you need to understand or count information in an image, you definitely would want an object detection model. Um, so that's something definitely to always consider. What is the output ultimately that I'm looking to gain from my image? And how consistent or variable is it? And usually the less consistent, more variable are going to point you towards those object detection or potentially segmentation projects and model types. And an intuitive interface to actually come in and label, you don't have to be a data scientist to come in and generate something like this for your own store. But here, the value of a Marvic solution is that there's the post-processing of that object detection JSON results into a spreadsheet. So I always think when we talk about AI and ML solutions, the model piece is very impressive and interesting, and that's the technology. But what we actually are excited about is that spreadsheet, being able to auto calculate the percentage of brand share from those JSON results. So again, we always sort of break apart any given project and think about the data modeling and deployment and how that parlays into the customer's actual human process today. And you could read a little bit more about that. I've listed all of the links here, and we can provide that in the after email that we'll send after the webinar. But really interesting use case here for a computer vision application. And the last one here, looking at life science. Obviously, if you think about anything with a microscope or any lab environment, there's a lot of image systems that are in those environments. And there's a lot of time-intensive, research-focused tasks that come with that analysis. And AI can really help the human in those tasks day to day. And in this case, looking at actually counting cell colonies. So imagine a petri dish with a ton of different potential cell types or one cell type. They're very small, and counting that as a human is challenging, or even using systems to help do that. So using a deep learning solution to actually segment them and count them is hugely valuable, and it allows those researchers to spend less time having to become ML savvy and build models themselves, and also lets them focus on other more interesting research studies within the lab itself. And using LandingAI systems, obviously the inputs are dramatically reduced. So we're looking at here 84% reduction in model creation time. And you're not then spending tasks and time labeling. You can do other things. So the components here is much more straightforward from a solution perspective, because this is almost end to end using LandingAI, because the deployment is using our QR code endpoint. So all you have to have is your phone and the ability to review the images in a more consistent manner. So potentially placing your phone above the cell colonies in a specific way, and then being able to count those cells using that endpoint. So very straightforward process and very impactful to see those results from sort of the data itself of the cell colonies, developing the model itself, and then leveraging the LandingLens QR code endpoint. So those are some examples that we see across different three major industries. And now what I'll actually do is go through and do a demonstration of a recent release. But before, just a reminder, you can join the chat through the LinkedIn event page that you registered, and we'll be able to see your thoughts, questions, and comments. All right, so a recent feature that we released is around being able to compare models, and this has been a common customer request, and something that you see data science teams put a lot of process around, so that you can show consistency and reliability in your model output, and it's really helpful when you think about iterating on model, because they always say once you deploy a model, it's no longer active. It's because models are not static. There's new data constantly that potentially may evolve, and so being able to add new data, train a model, and then leverage the same gold standard test set or evaluation set allows you to see, is this model, this new iteration, ready for production, while being able to maintain your current model already in production in the wild. So a lot of complexity here, but here in our environment, you'll see that it's a very intuitive point and click interface. So now we'll step over to the LandingLens platform. And you can see I'm right here in our demonstration organization. I have a use case where I'm trying to identify different adapters and whether they are in a good or bad state. You can see from this drop down that I have two different model versions. One where I trained an initial set of data, and then somewhere I took some images in the wild and I wanted to add them because they represented different situations that I hadn't encountered before, and I wanted to make sure the model was able to take that information into its training and ultimately understand those new scenarios and environments. So we auto generate those snapshots. It can be very useful for then actually setting up that evaluation set where you're consistently sort of looking at what is the performance of my model, not just every time I hit train with what we auto pull as a what is technically in our platform a dev set, but truthfully a test set for the model itself. And so obviously I see those two different snapshots there, so that's perfect. But let's say I want to test for that consistent data view. It's very straightforward to come in and go on my models page and add that evaluation set. So you can see here with our two different snapshots of the model as it was trained, I can see how the model performed, and this is the F1 score here, which would be the same for object detection. And then for segmentation, you would see the score for the IOU for that intersection over union, and what the performance was on the dev set. So 20% of the overall data that was loaded is then used to test the model, to give it a quiz and see what the ultimate performance was. You can also set your test set yourself. So we allow you to sort of override the auto configuration and apply that yourself. But in addition, now it's even more straightforward to add your evaluation set. So in this case, I want to use the snapshot created from my latest generated model, but I only want to use those images that were tested. And this is going to be my consistent standard across any iterating that I do in the model, because I saw examples for identifying defects on those adapters that I want to make sure I can always account for. And that's something that's great when you're going back to your compliance team and trying to showcase the consistency from these models that you do. So I can select to do all or the train or the dev, and I can even add multiple, but in this case, I'm just going to add the dev, and then ultimately evaluate that performance here. And I can add additional if I would like as well. And you can imagine in complex systems where potentially there's been many iterations of the model over time, you may want to favorite that and then sort of reduce the noise in your set of tables and rows here. So you can favorite a model and then only show that one, which has a lot of value as well. But in this case, it's great to see that consistency in performance across the different trainings. And with a lower percentage of performance, that's likely an indicator to me that I need to go out and get more data, train the model again, and then I can come back and test it on that same test set and see if the performance improves. So really simplifying the overall complexity in this model operations pipeline and allowing for that consistency in testing. So it's a very common challenge and really great to be able to do this in a point and click interface. So that's what I plan to show you from a platform perspective today of the new features, but always please do pay attention to our documentation. So we have a great walkthrough of that exact feature available on our support center, so support.landing.ai. And it's also great to come and actually look at the release notes that are made available. You can even just search release notes. To see that as it comes out, and you see the pretty consistent clip with which we provide updates to all of our customers. And with that, we'll turn it over for questions. So I think there was a few that were provided in advance. Is that right, Adrian?
Yes, and we actually got some live questions. So let's start with those.
Great.
First one, is object brand detection the goal or beyond classification?
Can you repeat that question one more time?
Certainly. Is object brand detection the goal or beyond classification? And they had classification in parentheses. Does that resonate?
Yeah, so you're still typing the different brands that are available, but the mechanism to do that is using an object detection model. So the end goal is to calculate that percentage brand share, and then the different pieces used to actually achieve that is an object detection model. So you're putting a bounding box around each individual product. And those products are identified by brand. So you would have a class in that object detection model that was Coke or Pepsi. So ultimately, in this case, you wouldn't be able to leverage classification because there is not a dominant brand across the whole image, and you can't use that output from the model to determine that brand percentage. So that's why in this case, because of the goal to calculate brand share, we ultimately end up leveraging object detection. Hopefully that makes sense and I addressed the question.
Great answer. Let's go to the next one. Is the model going to identify the duplicate products?
So what it does in this case is absolutely identify for the number of products on the shelf that in this case are Coke or Pepsi. So for example, if there are 200 uh, soda bottles on the shelf, what percentage of those are Coke or Pepsi? So you're parsing the results from the object detection model to say, there are uh, 20 Coke bottles and 80 Pepsi bottles, and then say the percentage of each brand that's ultimately on that shelf. And a lot of times there are store owners that have percentage share that they have to include. And you can also think about generic brands as well. So there might be a class that ultimately is just looking for generic. So at the end of the day, you will count the number of Pepsi bottles as kind of duplicates, but you're not managing individual unique SKUs. So I think that answers the question.
Excellent. And we had some questions from the survey. So let's kick off with that. First question.
Great.
How are the default images training resizes decided? Let me repeat that. How are the default image training size resizes decided?
Great. That's a fantastic question. So, from a platform perspective, when we look at our different model or project types, so we have object detection, we have segmentation, we have classification, we have visual prompting. As part of the model pipeline that we handle behind the scenes, those images, so let's say you load a very large image, when it's used to train the model, we resize that down typically. So, for example, segmentation images are resized to 800 by 800. You have the ability to customize that resize, but our default um, resizes are um, based on our own understanding of common image input. So, just knowing sort of roughly what what is out there for those types of projects, and then more importantly, really around the benchmark testing for speed and accuracy based on that size. So, um, that's just our best practice and gold standard. But by no means, based on your use case, does that mean you have to stick to 800 by 800. You can use the custom training option to perform a data transform to change those sizes based on your own use case goals. And our support uh, center provides a lot of information around this. And we also, based on your package with LandingLens, support actually very large image size model training. So definitely read through that.
Excellent. We had a few more questions submitted from the survey, and they're great questions. Next one. Should I consider using a LVM or foundation model?
That's a great question. We've gotten a lot of inbound interest just based on our own release of and discussion around LVM. And so, as a large vision model, the ultimate goal for an LVM is to really understand the feature space of your image set. So if you think about your use case and you see that it's not typically represented in publicly available image data, and you have a lot of that data, so if in your domain it's in the hundreds of thousands of images, you're likely a good candidate for getting the benefit of an LVM model, which is really to help accelerate the time to develop custom models and develop and improve the performance of those custom models so that your downstream applications, so if you're um, analyzing you know pathology images, you're able to do that more and faster and with higher accuracy. So a lot of benefit there. But definitely think about, do I see other images when I'm, on Google and just searching around the web that look similar to mine? And if not, then definitely likely LVM could benefit you.
Great answer. Let's go to the next one. And what are some of the common post-processing tasks done with model inference results?
Yeah, it's always important to think about your output of the model. So for example, if you run a classification model and you're looking at the output of good versus bad, there's typically also a confidence score associated with that result. And do you need that confidence score and that information in your downstream task? So sometimes, a common task might be looking at that confidence score and alerting the human to come take a look based on the model's, if it's 99% confident versus 25%, it might be that that good or bad indicator from the model needs to be reviewed by a human. So that's a very common post-processing task, but others can we actually have code examples from our SDK to help you, but is really around like we looked at in the brand retail shelf share calculation use case, is around counting or doing some sort of measurement. So if you think about the output from about object detection model, it is the bounding box and there are coordinates of that, and you can use that to measure. So for example, if maybe you were looking at inspecting different pills and there was a defect size that would then shut down the line, you could parse that OD output to then sort of make that stop happening. And the same goes for segmentation masks. So usually segmentation is for use in use cases where the objects are more irregular shapes. So that calculation can be very valuable, especially when you think about healthcare type use cases. But those are the most common, is really counting, measuring output, or using some sort of analysis on the model output itself based on the classes. So if, for example, you are, based on the model output, going to perform a next task using if it's good or not good, or the confidence score, as I said.
Excellent. We have time for two more questions. Next one is there a limit for the number of classes?
Yeah, this is from a technical perspective. There is no hard limit on the number of classes, but it's really important from how you're teaching and training your model and what you want it to understand to consider how visually distinctive your classes are. Because a lot of times I see very long lists of classes that are all very similar. And a lot of times there's a subject matter disagreement between those different classes. So should you potentially merge those classes together to reduce the model confusion and improve your accuracy, your precision and recall? Potentially. So always ask yourself those questions. And, of course, you can train a model with many classes and see that potentially it's very confused. And then you can create a new project or train a new model by adjusting those classes. It's really easy to iterate in the platform that way. And the other consideration to make is just from a UI perspective, once you have so many different objects of interest, labels, or classes, it's kind of hard to view your calculated metrics. So if you look at a confusion matrix, or even just labeling and trying to select for one defect type versus the other.
Awesome. And we have a great question here. And this will be our last question. What considerations should I make for choosing a vision project?
Of course, this is a pretty complex question, and there's a lot to consider. But some good tips to get started is make sure data exists. A lot of times, setting up an image acquisition system can be time intensive or cost intensive. It really just depends. Or maybe the environment where you want images to be performed is sensitive. So don't focus on areas where it would be really challenging to get that incorporated. Focus on where the data exists. And I think if you're looking from an operations perspective as a business, it's great to maybe have a call for data at your company. So really look to see across the different business units, where is imaging happening today? Is it with an operator, or is it with humans who are out on the field with their cell phones? And then think about how maybe those humans could be assisted with AI. And if data does not exist, is it easily accessible? So really, is data there is the first to think about. And then a lot of times we see sometimes use cases that are challenging even for humans to agree what is what. So very subjective or vague uh, uh, outputs, or even vague goals. So if you don't really know what ultimately you want to achieve, it can be very challenging to try to parse what a model would try to take as input and provide as output into your system. So definitely focus on where there's strong agreement, and where you have very clear goals and understanding. And then, of course, the final thing to always consider, and probably maybe the first to start, is what is the value that bringing AI into the process provides. And to do that, you need to understand what's the cost of the human process today, how accurate is it, what does it add if the AI assists or replaces? Is there some other cost benefit coming from that? Just like we looked at some of the examples where it reduces turnover and helps operators become more proficient in their own jobs. And then if you're bringing AI into the equation, is that something that exists already at the company, or is that going to be a big cost investment to set up initially? And from a repeatability perspective, am I looking to do something once? Do I need more of just a very simple one, uh, just one model to solve? Or can this be used elsewhere? And this will help build a case for ROI. But those are, you know, does the data exist? Is there agreement? And what is the value? So those would be the top 3 tips.
Great Q&A, Erica, and a great presentation. Couple of things that I want to offer is for everyone, for our global computer vision community, we're offering a no-cost consulting time with a LandingAI specialist. And really what we want to do is go over your business case, understand your use case, what's the feasibility of that, have that conversation around solution recommendations, and obviously cost considerations and potential next steps. So there is a link there to a calendar from me. So if you'd like to book that time, please take advantage of it. We really know that there's a lot of organizations that are looking to implement computer vision, and they're looking for a starting point. And we know everyone's on a different path of the maturity cycle. So we're here to help. So take advantage of this no-cost consulting time. It's a really valuable opportunity, and we want to share and learn from you. If we go to the next slide, one thing I would highly recommend is everyone sign up for LandingLens. It's a really simple application that's SaaS and secure. More importantly, upload your images so you can see how easy it is to build a model and train it. We have a community that is available. So if you have any questions, you can post it in the community. We're very active in that. In addition, we highly encourage you to get certified for LandingLens. It's a really optimal certification course. So please take advantage of it. As we close this out, thank you for joining us today. We will get a recording out tomorrow. And if you'd like to reach out to us today, again, to take advantage of that no-cost consulting opportunity, feel free to schedule some time with us. We look forward to chatting with you soon. And thank you again for your time. Have a great Wednesday.